is Dr. Holt. In this video I want to solve a problem where I have a man on top of a 150-meter building. He's going to throw a ball upward with an initial speed of 25 meters per second from the top of the building. We want to find out what is the ball's maximum height, how long is the ball in the air, and what is the velocity when the ball hits the ground. I want to show you a good way to do these problems. I like to make a kind of like a list of what I know and what I don't know. So I make a list as what I know and what I don't know. Okay, so I'm going to go down here and I'm going to circle what I know. Now I know a man on top is 150 meters. So right now I know delta y. Sorry, we'll make this delta y. This I know. All right, I'm going to throw a ball upward with an initial speed of 25 meters a second. So I know my initial velocity here. Okay. Other thing we know that gravity. We know gravity is equal to negative 9.8 meters per second squared. Okay, things I don't know. I don't know maximum height. And I don't know time. And I don't know final velocity when it hits the ground in the y direction. And I'll make this y here too. All right. I have listed all the equations here. Now this one, I like to often move the y initial to the other side, and I'll just change this to be delta y is equal to this equation here. So now let's go through and let's identify what we know. We know delta y here. We know our acceleration here, and we know this here. How many unknowns do I have? Well, I only have one. Time and time. Make that a little bit neater so you can see that. So time. That I don't know. That's a good equation. So there's only one thing I don't know in that equation. I come to this equation. What do I know? Do I know this? Yes. Do I know final velocity? No, I don't know that. Do I know time? No, I don't know that. How many unknowns? 2. Okay? So I can't solve that right now. I cannot have one equation with 2 unknowns. I come to this bottom one. Do I know delta y? Yes. I know my acceleration? Yes. Do I know my initial velocity? Yes. Do I know my final velocity or at any point in time? No. How many unknowns do I have? 1. All right. Now we're going to ignore the horizontal because this ball is only being thrown vertical, so we can ignore this right now. All right. What is the ball's maximum height? Well, to find maximum height, what do we know? We know that the velocity is going to go to 0. Well, I can use this equation. Now, I'm going to modify it in that I won't know delta y here because I'm going to try to find maximum height. So when I do that, I can come here and say 0. I'll do this in black. 0 is going to be my velocity at the top is equal to my initial velocity, which is going to be 25 meters per second. We will square that, plus 2 times negative 9.8 times delta y. Okay, I'm going to move this over to the other side, and that's going to become negative 25 meters per second squared is equal to 2 times negative 9.8. I should put meters per second squared there. I will this time. Times delta y. Now look what cancels. The negatives are canceled here. That's gone here, and that's gone here. All right, I'll grab my calculator. We'll take 25 squared on the left side. When I take 25 squared here, I will get a value of 625. Oh, sorry, I didn't mean to hit that. I will get 625 meters squared over second squared. Scroll down a little bit. We're going to divide by 2 times 9.8 meters per second squared. That right there is going to give me delta y, my maximum height. So we'll take that value, divide by 2 times 9.8. And my maximum height here is going to equal to 31.89 meters. Okay, so now we have maximum height there. So we were able to get that pretty easily. All right, let's go back to the equation. How long is the ball in the air? Now, we know delta y here. All right, there's a couple things you can do. If I want to find out how long the ball is in the air, I can go right to this equation right here, because the only unknown is time. And there's nothing wrong with that. That will give me the answer. The only issue is it's going to give me a quadratic equation. What I prefer to do often is, can I find the final velocity when the ball hits the ground? Yes, I can do that, because I can come down to this equation. The only unknown I have here is my v. And let me mark off this too. I don't want you to get confused about that, because I always said we know delta y, because delta y in this case is going to be negative 150. I'm following 150. So I'm going to take this equation we have right here, and I'm going to solve and find a velocity at impact. So I come down, I say v final squared is equal to my initial velocity, which is going to be 25 meters per second. We'll square that, plus 2 times negative 9.8 meters per second squared times delta y. Now delta y I am following. I am following a distance of 150 meters, so I will make that negative 150 meters. Now signs are critical, so be very careful when you read this problem. Okay, so I will go ahead and do the math there. You're going to have 625 squared, 625, and then plus 2 times negative 9.8 times 150. That's going to give me 3565. We take the square root of that. And that's going to give me a velocity final when it hits the ground. And remember, when you do the square root, it's plus or minus. That's going to give me a value of negative 59.707. I'll make it 708 just for rounding purposes. 708 meters per second. So that's my velocity at impact. All right, to find my time, now I know my velocity at impact. I come back to the equation, and I could go right here and go right to this equation if I want to and not deal with the quadratic, because I know what my final velocity is. I know my initial velocity. All I have to do is find time. So we're going to use this equation right here. Scroll down. I'll rewrite the equation. V final is equal to V initial minus 9.8 times t. V final. Make sure you put negative, because you're going negative when you hit the ground. Negative 59.708 meter per second is equal to my initial velocity, and initial velocity again was 25 meters a second. Minus 9.8 times t. I will move the 25 over, which makes it negative. So over here, I have negative 84.708 meters a second is equal to negative 9.8. Again, you guys should put the units on here. I'm not as careful as I should be. Divide by negative 9.8. And I get a time of 8.64 seconds. Okay? All right, so I was able to solve everything I was asked here. I was able to solve maximum height. Maximum height, throw that ball straight up, it's going to go 31.89. How long is the ball in the air? Well, we just figured that. That is 8.64 seconds. What is the velocity when the ball hits the ground? And in this case, since you have no horizontal velocity, the velocity is going to be 59.708 going down meters per second. Anyway, it's a short video. I hope it was useful. Again, I highly recommend that you use a table method like this. Identify what you know and what you don't know when you start the problem. Then go through and put a check by what you know, put a circle by what you don't know, and list how many unknowns you have. Because that way you know immediately when you see 1 here, 2 here, and 1 here, you're either going to work with this equation or this equation. You're going to stay away from this because you have 2 unknowns. Anyway, best of luck with these problems.